So here, what is the method is like, what is a block? Block, it is, I'll call YA, and this distance, let it be XA. Then we'll define, let this be equal to say some H, and this H is a constant, no? Overall length of the string remains constant, will agree? The overall length of the string should remain constant. The length of the rope should remain constant. So what is the length of the rope? We'll define first. The length of the rope should be equal to H minus YA plus root of XA square plus H square. Will agree? The length of the rope. And we know one thing. What is that? The length of the rope will be constant. So L, what is L? Length of the rope. So overall length of the rope, you see this. This everything is length of the rope. And we know the rope is inextensible, no? So the length of the rope remains constant. So here I'll differentiate now. So dl by dt. This will be 0 minus dya by dt. This will be 1 by 2 xa square plus h square. Then derivative of xa square will be 2xa dxa by dt. So this should be 0. What is dya by dt? This should be the velocity of block A. 2 get cancelled. So xa by root of xa square plus h square. So dxa by dt, what it will be? Sorry, dxb symbol. Let a bit. I'll change it. This will be. Carefully make observation of symbol. Xb, that one. So dxb by dt, you know. Differentiating this. So what is dxb by dt? Should be equal to velocity of the block B. Write it here now. So this should be equal to 0 equal to minus VA. What is xb by root of xb plus h square? So that should be equal to cos theta. So therefore VA equal to VB cos theta. So like this is what the constraint equation are related. So the speed of block A is equal to the speed of block B. At that instant, if you want acceleration, that also we can write it here. Acceleration of A is equal to only at that instant. So I think when string is not vertical, I think you have to be careful, no? Sometimes the string will not be vertical, it makes some angle theta. Then the constraint equation depends upon that angle made by the string. This is one thing. Now I'm going to tell you one very important thing. We know what is that? The string is inextensible, no? So shall I bring one basic idea? The velocity of the ends along the string must be equal, and the string is inextensible. I'm putting one bold statement. The velocity of ends along the string must be equal as the string is inextensible. I'm taking help of this idea. So what is the velocity of end B? VB, no, but how much its component velocity of ends along the string? What is the velocity of end B? VB along X, but along the string, how much it should be? VB cos theta, that should be equal to what is the velocity of end A? VA along the string. So VB cost equal to VA, finish directly, you can predict. No need to really struggle with all the mathematics. This you could have also done by this particular statement which I give. So what this statement will tell us, what is the velocity of NB? So I'll give a rough diagram. No, page break is there. I'll give small diagram here. So you could have even thinking like this also, there's no problem. So what is this angle? Theta. So resolve this, this will be theta. So what is the velocity of end here? VB cos theta, VB sin theta. What is this end? VA. This string. So this string. So what you should measure? The velocity of the ends along the string must be equal. What is the velocity of block B? VB. How much along the string? It is VB cos theta. So therefore that VB cos theta should be equal to VA. I think that you can bring it. No? I'll rewrite once again. It has come to at the end. So there's a one thing. So you can immediately tell the answers here. So no need to struggle. Okay, fine. Where all you want. So you're supposed to take help of this condition. We'll take the next condition.